Guys, can you confirm? Can you hear me? Yeah. Yesterday we have completed what is JVM, why JVM, how to start JVM, and when we start JVM, what happened background, we have clearly understood in last class. So hope no need to tell again, right? So when you run Java command, JVM is started as a process in OS by occupying some memory from RAM. Then in order to execute the given class, the class bytecode must be loaded into JVM memory. By keeping the bytecode inside hard disk, we cannot execute. We must load the bytecode into JVM memory. Then after loading, okay, it's a verifying. After verifying, interpreting. After interpreting, now machine language generated. And then now we'll get output. Okay. For now, we completed JVM related points. Now we are trying to understand JVM architecture. So what the meaning of JVM architecture? JVM architecture is nothing but set of boxes. Simply, I can say architecture is nothing but set of boxes. Those are meant for storing the class bytecode and running the class bytecode. Simple, you should understand JVM architecture is nothing but how JVM will execute our class, how JVM store our class bytecode, and how JVM execute our class bytecode is what we are trying to understand as part of JVM architecture. Then, if you want to understand how JVM execute your class bytecode, first of all, you should know, right? First of all, you should know what are the different members we can create in a class, right? What are the different members we can create in a class? You should have an idea. Then now, I'm trying to, yeah, I'm trying to show you what are the different members we can create inside a class. And you know, inside a class, variable chapter we discussed. We are writing a class for what purpose? For representing real world object and storing that object values and implementing that object operations. If you understand variable chapter and method chapter, you must come across one common idea. Inside a class, we will create two types of members, that is static members and non-static members. So static members are meant for storing values and executing logic common to all objects. Non-static members are meant for storing values and executing logic specific to one object. Then how many static members are there? 5 static members. How many non-static members are there? 5 non-static members. What are the 5 static members? Static variable, static block, static method, main method, static inner class. How many non-static members are there? Exact opposite. Non-static, static variable, non-static variable, static block, non-static block, static method, non-static method, main method, non-static main method. Right? Do you have non-static main method? Come on. Do you have non-static main method? No, right? We don't have non-static main method. In place of non-static method, we have constructor. Non-static variable, non-static block, non-static method, and constructor, following by what? Non-static inner class. Yeah, you have come across all the blocks, all the variables, all blocks, how they look like, everything, you got clarity, right? And then finally try to answer. Inside a JVM architecture, understanding JVM architecture is nothing but learning how JVM execute our class. For that purpose, you need to understand one thing. What are the different members we can create inside a class? What the purpose of them? Static member, when should we use static members and when should we use non-static members? When we want to store value and execute logic common to all objects, we must use static member. When we want to store value and execute logic specific to one object, we must use non-static members. Then what are the members got executed by JVM automatically? JVM executes, okay, a member which has a chance to execute only one time in the lifetime of a class. Again repeating, JVM executes one member that has a chance to execute only one time in the lifetime of a class. Tell me, will JVM execute all static members? No. JVM never executes static method. JVM never execute static inner class. JVM executes static variable automatically. JVM executes static block automatically, and JVM execute main method automatically. Because these three members have a chance to execute only one time in the lifetime of a class. Other members are executed only when programmer involved. Only when programmer calls static method, JVM execute. Only when object is created, JVM execute non-static members. Because static method, non-static member have a chance to execute more than once. Among all these members, JVM executes only static variable, static block, main method automatically. JVM executes static method only when we invoking. JVM execute non-static members only when we create object. Because static way method, non-static member have a chance to execute more than once. Hope you understand this point. Then tell me how to create a class. A class recommended structure with both static members and non-static members. Class bank account. Inside class bank account, first we create always static variables. Then we create non-static variables. Then we create static block, non-static block, and constructor. Following by we will create static methods and non-static methods. These static, non-static methods are meant for either storing values in object, reading values from object, modifying values of the object. Okay, performing any operation, we will use methods. And then following by common methods like displaying values. Static, non-static variables values displaying. Then static inner class and non-static inner classes we will create. This is the basic structure of the class. But inside this class, if main method is not there, we cannot start running this class. So I'm including main method also. You can write main method anywhere you wish. Anywhere you wish, okay? Then, now tell me. If I want run this class, when I run this class Java bank account, then JVM by default execute how many methods, how many members? Only 3 members. First, it will JVM Java command will create the JVM and load bank account class bytecode inside JVM and execute static variables, static blocks, and main method only. Okay, the remaining members, non-static variable, non-static block, constructor, static method, non-static method, common methods all executed only when we call them. So what the step number? When you run Java bank account, first bank account class is loaded, static variables memory allocated, static block executed and static variables are initialized, main method executed, execution started. As part of main method, if you call static method, if you create object, static method, non-static members are executed. Hope everyone understand. First, you need to understand this slide. Got clarity here? Yeah, please write down this slide. Then we will go for JVM architecture diagram. Write down this slide. Now let us try to understand JVM architecture block diagram. What is the meaning of JVM architecture block diagram? Just visualize like this. JVM is a JVM occupy some memory from. Okay, let me try to draw from here. Java C example.java. You compile the class. Okay. .java. You will get .class file stored in the stored in the hard disk. Then Java example you return. Okay, I'm assuming this is the JVM Dabba. Okay, JVM is prepared by occupying some memory from RAM. I want to move it little down. Okay. And this memory is divided into some parts. How many parts it divided? Let us try to visualize. Now go back to the previous diagram. First step is what? When I run Java command, first JVM created. Yeah, JVM created as a process by occupying some memory from RAM. Second step is what? JVM must load this class into, so JVM must load this class bytecode into JVM memory. So the first step is what? Loading this class bytecode inside JVM. Where it is loaded? This entire JVM memory occupied? No, right? Not required. This entire JVM memory no need to occupy. Okay. Some part of the memory will be occupied for storing this class bytecode. Then after, once the class loaded into JVM, next step is what? It should allocate memory for static variables. Then tell me, where the static variables memory allocated? Wherever the class bytecode is loaded, there only static variables memory allocated. Na? Wherever the class bytecode is loaded, there only static variables memory allocated. Achha. Then now two things should be happen. Number one, class load into JVM, class bytecode load and stored inside JVM, static variables memory allocated. Okay, fine. Then after static block logic, main method logic must be executed. Then where in the same place wherever it is loaded? No. For that purpose, I required some other place the static variable, static blocks, static blocks and main method logic will be executed. While main method logic execution, I may call static method, or I may call what? I create an object. Then tell me, when we create object, where object memory should be created? Static variable memory and non-static variable memory should be clearly separate. Na? So we require one more place where non-static variable memory allocated. Then now my point is, whenever you try to take JVM architecture, you must visualize JVM architecture in terms of what? Memory blocks. How many memory blocks will be created? Now you need to decide. So first memory block for storing static variables, for storing class bytecode and allocating memory for static variables. Second memory block for creating instances and allocating memory for non-static variables. Then third memory block is for creating threads. Okay, what the pointer? Threads. Third memory block is for creating threads and loading and executing static block, constructor, static method, non-static method, main method logic. Methods logic is executed here. Everybody got clarity? Yeah? Then now I have a question, carefully think. I have main method here. Inside main method, I call M1 method. I call M2 method. I call M3 method. Now control is in M3 method. After M3 method execution completed, control must go back to the calling place M2 method. Then M2 method logic should be resumed from the line where M3 method is called. Then after M2 method execution completed, control should go back to M1 method. M1 method logic execution should be resumed from the place where M2 method is called. After M1 method execution completed, control should go back to main method, and main method execution should be resumed from the line where M1 method is called. Then my question is, how JVM can remember? How JVM can remember which method is called, what line is running now, from what line to what line it should go, how it will remember? For that purpose, it is having one more memory block. In this memory block, all the instructions executing in this thread will be tracked by using some special memory area. By using some special memory area, the instructions executing in this thread will be tracked. And then last, now tell me, there are two types of methods are there. Methods which contain logic in Java, the methods which contain logic in C and C++. The methods which contain logic, Java method only, method declaration in Java, but its logic is written in C and C++. Now, this Java method declaration can be linked to C, C++ method declaration, method implementation. That linking method, that Java linking method is called Na2 method. Okay, so here in this thread, what methods are executed? Java methods executed. Means the Java methods which contain the logic in Java will be executed. But the Java methods which contain logic in native logic C and C++ will not execute here. For execution purpose, we have separate memory area is there. Okay, separate memory area is there. Then finally try to answer, how many memory areas JVM is divided? JVM memory is divided into 5 runtime data areas. How many runtime data areas? 5 runtime data areas. Okay, JVM memory is divided into 5 runtime data areas. First runtime data is called method area. Second runtime data area is called heap area. Okay. Java stacks area. Next memory area is Java stacks area, and this one is program counter register area. PCRA, program counter register area. Okay, and this is called Na2 method stack area. Okay, because space problem writing shortcuts. It is called Na2 method stacks area. So whenever you run Java command, JVM is created as a process by occupying some memory in RAM. Okay, then first runtime area is method area, heap area, Java stacks area, program counter register area, Na2 methods stack area. Then tell me, after this memory, after this JVM is created, JVM divided into this. Here in Java stacks by default we have one thread. What is the name of the thread? Main thread. For this main thread, what will be here? Main program counter register is created for tracking the execution of the instructions running in the main thread. Then inside Na2 method stack, we have one thread is created, one stack is created for what? Main. This is a main Na2 stack. Main NS, main Na2 stack is created. Hope you all understand. So this is the basic setup done by the JVM by itself. Now my question, after JVM is created, now JVM software should execute example class. Example class is not available in JVM memory. Okay, now Java command created, JVM completed. Then JVM searching for this example class in a method area. In a method area, the example class available? No, right? Because if you want to execute class bytecode, this class bytecode must be available in method area. In method area, the class bytecode is not there. Then it requests whom? Any of you remember? It requests whom? It requests class loader. It requests class loader to search for this class bytecode and load inside JVM. Again repeating, JVM searching for the example class in JVM searching for example class in method area. It is not available. Then who is responsible to load the class? Class loader is responsible to load. Then class loader is given a request to search for example.class file, read its bytecode and store the bytecode inside JVM. Then now try to answer class loader alone cannot work to load the class. Class loader implicitly using some class loaders. Multiple class loaders are there. What the class loaders it is using? Number one, it is using application class loader. Okay. Now application class loader. For example, assume class loader is nothing but Naresh sir. Naresh sir is using internal faculties to teach. Okay, internal managers to manage the complete classes running in the Naresh IT. Naresh sir will not do all the management works. Naresh sir is having some managers to take care of all the management work. So like Naresh sir, class loader is also having some class loaders. Why it is having other class loaders, I will tell you at this minute, just to try to accept. Okay. Then another class loader also it is having, that is extension. It is having one more called extension class loader. One more class loader we have, extension class loader. Okay. The next, we have one more class loader called bootstrap. We have one more called bootstrap class loader. We have one more called bootstrap class loader. Okay. So totally how many class loaders we have? We have 3 class loaders: bootstrap class loader, extension class loader, and application class loader. Here, application class loader is the subtype of extension class loader. Okay. And extension class loader is a subtype of application class loader, is subclass of extension class loader. Extension class loader is subtype of bootstrap class loader. All these 3 class loaders together, what we call class loader subsystem. Again repeating, all these 3 class loaders are called class loader subsystem. Okay. Then these is why we have 3 class loaders. All these 3 class loaders are technically called okay. All these 3 class loaders are called class loader subsystem. Why we have 3 class loaders? Because the class you are asking to load into JVM, it is available in 3 different class paths. I hope you know what is a class path. Class path is nothing but the place where class is available. It is available in 3 class paths. Number 1, predefined class path, C:/JDK/ any version I'm taking. Okay. JDK, let's say JDK 1.8.0 underscore some XX version /JRE/lib/rt.jar and other jar files. Okay. Now all the predefined classes are available here to load. Tell me, in your project you are using predefined classes now? right? All the predefined classes are loaded from here. This class path is technically called bootstrap class path. Okay, all these are called bootstrap class path. Why these are called bootstrap class path? Because these classes are meant for booting the JVM. Booting means starting the JVM. The next, we have some other classes which can be available in another path called C:/JDK 1.8.1.8.0 underscore XXX. XXX is nothing but any version number. JRE slash lib slash. Here there is a folder called ext. Inside ext folder, there are so many other jar files are there. Maybe classes are available in extension directory also. Okay, classes are available in predefined class path, are also available in extension class path. This is called extension class path. The next, classes are also can be available. Classes are also can be available in application class path. What is application class path? Is nothing but class path environment variable equal to dot semicolon and some other folder path semicolon. Okay, dot semicolon, some other folder path semicolon, or some other folder path semicolon, some other folder path semicolon. Okay, like this. And last we have percentage, existing percentage class path percentage. If you want, you can write, otherwise ignore it. Okay, now this class path is called what? Application class path. This class path is called what? Application class path. Hope everyone understand? Then tell me, Bootstrap class loader is responsible for searching the class and loading the class from Bootstrap class path. Extension class loader is responsible for searching the classes and loading the classes from extension class path. And application class loader is responsible for searching the classes and loading the classes from application class path. Then now the question, whenever JVM send the request to class loader will hand over that request to whom? Application class loader will give the request to application class loader. Then application class loader must search for the class where in application class path. If the class is found, it should read the bytecode and store the bytecode inside method area. But here application class loader will not search the class inside application class path directly. Rather, it delegates the request to its parent extension class loader. Okay, it delegates the request to its parent extension class loader. Then extension class loader should search for the class in extension class path. No, if it is found, it has to load the class inside method area. But extension class loader directly not searching for the class in extension class path. It is searching, it is delegating the request to whom? It's a parent Bootstrap class path. Then Bootstrap class loader will search for the class in Bootstrap class path. In a Bootstrap class path, either in rt.jar file or some other jar files, if the class is available, the class is loaded into method area. If it not available, obviously not available, example class is not available in Bootstrap class path, then it throw exception back to extension class loader saying that the class is not found. Then extension class loader catch that exception and searching for the class in extension class path. Then extension class path, if the class is available, then extension class loader load the class and store the class inside bytecode inside method area. But obviously our example class not available in extension class path, then it will throw exception to application class loader saying that the class is not available. Then application class loader searching for the class in application class path. Okay, in application class path also, if the class is not available, then extension class loader will throw an exception. I mean, application class loader will throw an exception. What the exception? Class not found error, or no class def found error. No class def, sorry, class not found exception, or no class def found error. Any one of the exception we will get. If the class is found, okay, if a class is found somewhere in any one of the class path, then the class is loaded into JVM and stored inside JVM. Hope you all understand. And now tell me, class loader subsystem is working on an algorithm, what? Not searching directly, delegating request to its parent. Hence, this algorithm is called parent delegation hierarchy algorithm. What this algorithm is called? Parent delegation hierarchy algorithm. Okay, question number 1. Here I want you answer 2 to 3 questions. After understanding parent delegation hierarchy algorithm, I want you answer the questions. Question number 1. Why parent delegation hierarchy algorithm is following? Why application class loader directly not searching for the class in application class path? Why it is delegating request to its parent? Question number 1. Okay, simple point. Array, if you practice identifiers chapter, in identifier chapter I told you we can create our class name with a predefined class name. For example, I can create my class with the name string. Class string we can create. Then in my project, if I use a class string, then the class is loaded from where? From the application class path. So if I create a class with a predefined class name, then predefined classes are never loaded into JVM. You may ask me question, sir, I can show difference between predefined class to user defined class by using package and sir. Yes, by using package you can differentiate, but the question is you can also create package also with a predefined name. So complete package name, class name, everything you can create with a predefined name. So if you create complete package name and class name with the same name as a predefined name, then the class is never loaded from the predefined classes. Hence, Sun Microsystem decided they wanted to first give the priority for loading predefined classes. Hence, parent delegation hierarchy algorithm is implemented. Everyone understand? Question number 2. Question number 2. Okay, if they wanted to load predefined classes first, then why request is given to application class loader delegated to extension class loader delegated to bootstrap class loader? Why directly the request is not given to bootstrap class loader? Okay, if a directly request is given to bootstrap class loader, then if the class is not found in the bootstrap class path, again request is coming to class loader. Then class loader should make a request to extension class loader. If not available, again class loader should make a request to application class loader. Then number of requests are manual. Then in future, if you want to do any changes in the hierarchy calling, then again you have to do changes in the class loader. To make it dynamic, to make it automated, what they did, application class loader, child to parent, parent to parent. If not available, come to child. Not available, come to child. So implicit calling, they make it as automated. Okay. Why class loader subsist? Why class loader not calling bootstrap class loader directly for loading the predefined classes first? Because if class loader called predefined class, I mean bootstrap class loader directly, now if class is not available in bootstrap class path, it cannot come to extension class loader, cannot come to application class loader, because parent doesn't have child information, but child has a parent information. So that's why they have made a call as parent delegation hierarchy algorithm style. Okay, next, third question. Tell me, if the class is available, I am choosing one class called a.java. A.java, I mean a.class. A.class is available in bootstrap class path, also in extension class path, also in application class path here. Okay, a.class file is available in all three places. Then tell me, the class is loaded into JVM from which class path by which class loader? Class is loaded from bootstrap class path by bootstrap class loader. Are you catching my point? Right, if you don't give answer, I will give answer and I'll go. Okay, if you don't understand, that is your problem, not my problem. Okay, if you keep replying, I'll feel that either you are understanding or not understanding. Okay, if you're not replying, I'll feel that you are understanding, I'll go to the next point. Once I move to the next point, I'll not come back. That's why be careful, alert. Try to listen, try to reply to me. And now again repeating, if the class is available in all three class paths, first priority is always giving to bootstrap class path. Hence, a.class file is loaded from bootstrap class path by bootstrap class loader. Next, I have a class called b.class in, I have a class called b.class in, what do you call, extension class path, and also it is available in application class path. It is available two places. It is available in two places. Then b.class file is loaded from which place? It is loaded from extension class path by extension class loader. Now c.class file is available, c.class file is available only inside, c.class file available only inside application class path. Then the class is loaded from application class path by using application class loader. So this is also one of the important interview question, you should know it. Can I write a program to know my class is loaded by using which class loader? Yes, you can know it. We will write a program and I'll show you that. Next very important point. There is a small change occurred in Java 9 version. In Java 9 version, JRE software is deleted. There is no JRE. We have only JDK. Observe. In Java 9 version onwards, JRE Jamana gone. JRE is merged into JDK and call it as what? Java modules. Up to Java 8 version, we have JRE. Inside JRE, we have lib. Inside lib, we have ext. Inside ext, we have all these jar files. But from Java 8 version, Java 9 version onwards, we do not have JRE. Look at that. And we do not have rt.jar on anything. Okay, then now the question is, then extension class path mechanism is there or not there? Extension class path mechanism is not there. Extension class path mechanism is removed. Okay, extension class path is removed. From Java 9 version onwards, we do not have. From Java 9 version onwards, we do not have extension class path mechanism is not there. Okay, then listen carefully. From Java 9 version onwards, this what you call bootstrap path also got changed. The classes are not loaded from rt.jar. Bootstrap class path also changed. The change is c:/jdk hyphen 9.0 underscore xxx slash, there is no JRE. We have lib folder. Observe, we have lib folder. Lib folder contains look at it. Not lib folder. Directly we have jmods module system. Okay, jmods. CJDK 9.0. Okay, let me take yellow color. Maybe it's visible better. Array, how can I make you visible this? Yeah, from Java 9 version onwards, this path is gone. In place of that, we got module system. Okay, right. In module system, we have the path bootstrap class path. Classes are loading from this path JDK 9/jmods folder, and in Java, what do you call a 9 version, extension class path Jamana is gone. But extension class path is not actually removed. Okay, the name of the extension class path, extension fold, extension class loader names got changed. Okay, extension class loader name got changed. Let us go on to search. I forgot the name. Okay, there is some name I need to verify. Java 9 extension class loader mechanism. This is Java 8 version. Bootstrap class path, install extensions, the class path, class loading mechanism. Whatever I have explained, all points are available here. Okay. This is a Java 8 version document. Okay. Where does the extension class loader get classes? This is 1 year, 5 months ago. Okay. Let's see. Are there any answers related to Java 9? Look at here. All the documentation I have been able to find mentions the JRE folder, but such doesn't exist in my JRE 13 installation. I guess somewhere between Java 8, where I can see jars in ext folder, and Java 13 they moved, but I have been unable to pinpoint when and how it was done. Could someone please elaborate what's going on with the new JREs in terms of where the extension classes reside currently? Then one answer they have given. The extension mechanism is gone with Java 9. Not only moved, see the important changes and information from Java 9. The deprecated extension mechanism has been removed. The runtime will refuse to start if Java home libext extensions or system property java.ext directories is specified on the command line. And also the changes to the install JDK JRE image in Java 9 migration guide. In previous releases, the extension mechanism made it possible for the runtime environment to find the load extension classes without specifically naming them on the class path. In Java JDK 9, if you needed to use extension classes, ensure that jar files are on the class path. Hope you understand. So there is no extension mechanism. Earlier, the jar files which are there in ext folder, now you must place in the class path. Okay. Scroll down. Okay. Still, I wanted to go for another search. Yeah. Go down. Still, I am not satisfied. I wanted to search somewhere. Open in class loaders. Now, he is explaining introduction to class loaders, types of built-in class loader, bootstrap class loader, extension class loader. Okay, he's talking about old, okay, class loaders, system class loader. System class loader is nothing but application class loader. Okay, how do class loader works? Delegation model. Okay, I just explained delegation model. Okay, and unique classes, visibility, custom class loader creation, custom class loader use cases, creating our custom class loader, understanding java.lang.class loader, load class method, define find class method, get parent, get resource, context class loaders. Okay, this is a class load related more depth knowledge. Okay, this much depth knowledge at this stage we not require. This website also not providing ever information. What are the changes of class loader in Java 9? Open a new tab. All Java programs run on Java virtual machine. After compilation, a Java class gets transformed into platform and machine independent bytecode and compiled classes and class loader loads that class into memory. The classes get introduced into the Java runtime environment when they are referenced by name. The loading of the class has been done by using the method. Okay. There are few minor changes of the class loader in Java 9. The system class loader is no more in Java 9. An instance of URL class loader, rather it's an internal class. It is the default class loader for classes in modules. Okay, application class loader is converted to what? URL class loader. The extension class loader, okay, the extension class loader has renamed as what? Platform class loader. All classes in Java SE platform can be visible through the platform class loader. All classes in Java SE platform and also classes in modules under the Java community process, but not part of the Java SE platform, also visible through the platform class loader. Okay. So now again repeating, extension class loader name has changed as a platform class loader. Okay. Now I wanted to add that one here. Extension class loader place what the name came? Platform class loader. It is the came into picture. Platform class loader the name. Okay. Next, applications cannot depend on the class loader that define in which platform class of some classes in Java is platform defined by platform class loader, while others are defined by the bootstrap class loader. Okay. Now what happened? Some of the predefined classes are loading by using platform class loader. Some of the predefined classes are loading by using bootstrap class loader. Earlier, all predefined classes are loaded by using bootstrap class loader only. Now the sharing has started between bootstrap class loader and platform class loader. Okay. The platform class loader is not an instance of either, it is an internal class. Okay. That is internal class, you cannot use it. Bootstrap class loader is a built-in class loader in JVM. However, it defines the classes of critical modules such as base module. Okay, the applications deployed with hyphen bootstrap class path A or create class loader with null as a parent may not be changed. Okay, here they are given a small program where you can find which class loader using for loading the class. Okay, na class loader test.class get class loader. SQL java.sql.sql permission.class.get class loader, java.util.linked class. Okay, this is a base module class. This is the other than base module class. First class, our own class loaded by using application class loader, and this is loaded by using platform class loader, and this class linked list class is loaded by using bootstrap class loader. Bootstrap class loader name, bootstrap class loader name never displayed. The default value what you will get here, null you will get. So whatever the mechanism we have, same mechanism is following Java 9, just the names are got changed, that's all. Okay. So earlier bootstrap class loader, earlier bootstrap class loader only responsible for loading the predefined classes. Then now predefined classes are now loading by both bootstrap class. Some of the predefined classes are loading by bootstrap class loader. Some of the predefined classes are loading by platform class loader. Okay. So don't get much confusion. And anyways, just knowledge is sufficient. Don't think too much. Okay, just to have this knowledge is sufficient for you. Okay. So if you are thinking more deep depth knowledge, confusions will start. Okay, hope you got some idea on class loader subsystem. Okay, more depth knowledge. Okay, you can follow these articles. Okay, in your free time, just to go through them. Maybe you will feel comfortable while reading them. I'm teaching you how much how much is required for you. That much only I'm teaching. If you want more knowledge, okay, if you want more knowledge, you just go through these websites. Okay, now how much you require, that much only I'm teaching. I'm not going to much depth. He simply copy pasted whatever the document available in class loader class. Class loader is a predefined class. Okay, this website, where is this fellow? He just copied. This entire paragraphs are copied from Sun Microsystem documents. Okay, fine. So let us don't waste time here. Now, let me move to the next point. So finally, what you understand? How the class loader, how the class loader subsystem is working, you got clarity. Then now, please try to answer these questions now. Finally, either by Bootstrap class loader, or by platform class loader or extension class loader, or by application class loader, the class is found. Then the class is loading into JVM. Okay, tell me. Inside JVM method area, the example class of bytecode must be stored. Then tell me, the bytecode is just a dump like this? No, right? It should be organized properly. Then tell me, if you want to store any data inside JVM, if you want to store any data inside JVM, it must be stored inside memory. Na? We have two types of memories are there. Variable memory, expecting answer from everyone, and object memory. When to choose variable memory, when to choose object memory. If you want to store one value, then we use variable memory. If you want to store multiple values, we choose object memory. Okay. If you want to store one value, variable memory. If you want to store multiple values, object memory, we have to choose. Tell me, byte code is one value memory or multiple values memory? Byte code is one value memory or multiple values memory? Byte code is a multiple commands are there, na? Are yaar, one value memory. 5 byte code is a 5 value, 6 value, 7 value, right? Byte code is a multiple commands, right? So it's a multiple values memory. So tell me, byte code to store inside JVM, what we required? To store byte code inside JVM, we need one object, na? And the object is created by using one class. Okay? Then tell me, what is the name of the class? What is the name of the class that helps us to store from, what is the name of the class from which we create object for storing byte code inside JVM? Anybody guess? Come on, anybody guess? Come on. What is the name of the class for storing? What is the name of the class from which we can create object for storing class byte code? Let me give you a clue, okay? I want to store student data. Then what is the class you are using? Class student. I want to store employee data. Then which class you are using? Class employee. I want to store bank account data. Then which class you are using? Class bank account. Right? I want to store class byte code. Then what is the name of the class? I want to store class byte code. Then what is the name of the class? I want to store class information in Java. Class information in Java. What is the name of the class? I want to store class information in Java. What is the name of the class? Class information, class. The name of the class is class. Okay, got clarity here? The name of the class is class. Tell me, buddy. So if you wanted to store class bytecode inside JVM, Sun Microsystem has given a special predefined class called what? Class. For loading the class into JVM, we have which class? Class loader with supporting internal class loaders. In order to store the given class bytecode inside JVM, in order to store the given class bytecode into JVM, we have a predefined class called what? We had a predefined class called what? Class. Java.lang.class. Now this java.lang.class instance is created. Java.lang.class instance. I'm not calling it as an object because it's not representing any real world object. I'm calling it as only instance. Why? Because it's not representing any real world object. Student instance I call as object. Employee instance I call as object. But I don't call it as an instance as object because it's not representing any real world object. Then java.lang.class instance is created for storing class bytecode. Then all the people answer, inside this java.lang.class instance, what will happen? What will happen here? The class bytecode stored, which class? Example class. What the meaning of example class bytecode? It's internal static, non-static members only. Na? Then static variable declaration is stored here. Non-static variable declaration is stored here. Static method, non-static method, okay, static block, non-static block, constructor, then next constructor, the next static method, non-static method, main method, everything, whatever you defined inside a class, everything is stored inside this class example. I mean, in this class instance. Hope all people understand now. Rebuji. So now I want you to tell me all points with step numbers quickly. Are you ready? What is our target? I want to store the class bytecode inside JVM. Finally, class bytecode came into JVM, stored inside JVM. And now, sir, why you didn't write inner class? Hey, inner class is not part of outer class. After compilation, inner class dot class dot Because there is a chance as a programmer, you can create predefined classes with the, you can create user-defined classes with the predefined class names. And you can differentiate, even you cannot differentiate with the package, including package name also you can create. But from Java 9 version onwards, you cannot create your package name on predefined package name same. You can create class name same. String can be created same, but the package name cannot be same. Do you understand my point? Everybody got clarity? Again repeating. What I am imagining, what I am assuming, from Java 9 version onwards, parent delegation hierarchy algorithm would not be there. You send a request to JVM. Okay, you send a request to JVM. I mean, a class loader subsystem is send a request to class loader. Class loader giving the request to, it's my imagination, sir. Class loader giving request to no application class loader. Application class loader directly searching for the class in application class path. If not available, then only it delegate the request to no bootstrap class loader or platform class loader, whatever. Both are same, was searching for the predefined classes only, na? Then it is searching in a bootstrap class path. If they are also not available, final will get exception. Sir, prove it, and I cannot prove. Okay, I cannot prove this because we cannot store our class in the predefined class path. So why I am imagining this change would be done in Java 8 version, Java 9 version. The reason is we cannot create predefined classes with, we cannot create predefined classes. We can differentiate predefined classes and user defined classes by using package name. We cannot create our packages with the predefined packages. Everybody got clarity? Yeah? So that's why I'm thinking that if it is not available, then only go into bootstrap class. But that is what my assumption, my imagination. Okay, if you want me to prove, I cannot prove that. Okay, na? Right. So actually parent delegation hierarchy algorithm is slow in execution. So this is the complete story about JVM architecture, class loader subsystem working functionality. Okay, and whatever I have explained today, all points are there in your material. Can you please try to read once? All these 15 points are there in material. You can find it, class loader subsystem working functionality. Please read all 15 points. Tomorrow, I will continue remaining explanation. Remaining explanation is what? Runtime data areas and execution engine remaining explanation. Okay. Hope today class all you understood and enjoyed. Thank you. All this knowledge is necessary, sir, for future, okay? For future, all these points are necessary. Where JVM architecture material available? In Google Drive. Have you downloaded? In Google Drive, we have JVM architecture separate material. I ask you to download it. I don't know whether you downloaded or not. Yeah, Kumar, the evening batches are advanced batches, then you have to wait for your juniors, junior batch. Anuj, what do you want? Admin reply. For what you want? Drive note. When I'm giving in the class, why you are not taking? Why you people are ignoring when I'm giving in the class? That's why I don't want to give again. Why don't you save them properly? Use this link. Open JVM architecture material. Here download JVM architecture. And read in this material you have, whatever I explained today, every point is there, read. Thank you. See you all tomorrow. Tomorrow I'll start class at 9:15. Please be available. Today I started late because introduction is important. Tomorrow I don't wait for anyone. At 9:15 sharp, I'll start the class. Goodbye.